So 9.3 may take a little more calculations. Okay, a little more algebra that you gotta do. So let me open up the homework problem also. Okay, so I want to show you guys the example at the same time. You can see it. So right-hand side is our note for the today. And the left-hand side is your homework problem. Okay, this is 9.3 homework. And this is 9.3 lecture. All right, so 9.3 lecture. All right, so today we're gonna learn what? Integral test and a P-series test. All right, chapter 9 is all about whether this infinite series converges or diverges. Okay, that's the topic of chapter 9. So you need to have a tool to figure out whether this infinite series converges or diverges. So we learned so far what? What did you learn in 9.2? What series do you know which converges and diverges? Geometric series, you figured out your R. You look at your R, and R is what? Less than 1. Right? Absolute value of R less than 1, that converges. Right? But if it's R, the absolute value of R is more than 1, including 1, okay? It's equal to a more than 1, it diverges. That's the first thing you learn. Okay, what's the second one you learn? Telescoping series that you learn, right? You look at the telescoping and then you can see, okay, if I do this, it only remains with the first term and then what? Last terms. And I can take a limit of the last term that goes to 0, then whatever the first term is, whatever that is, right? So it converges. We learn those two. And then today we're gonna learn what? It's called integration test. So I look at my infinite series. The infinite series is not a geometric series. It's not a telescoping series. So you need to have other way to figure out. Is everybody with me? The reason that we're learning about the integration test is we don't know whether this converges or not. Like I know geometric series converges if R is less than or equal to what? Less than 1. I know that. I know telescoping series converges. I know that. But what about the other series, other infinite series that you don't know whether it converges or not? You gotta have some kind of test. So what's the test we're gonna learn? Integral test. Are you with me, class? So we need a tool to figure out whether this is infinite series converges or diverges. Like number 1. Okay, number 1, they say, okay, well, this one, you happen to know what that is. This is happen to be what? Geometric series. So you know this will converge because the ratio is 1/9, which is less than 1. Okay, but say, let's look at another one. Like this one, e to the negative n. Oh, actually, what about? Okay, class, a lot of stuff you can figure out without doing an integration test. Are you with me, class? There's many things you don't have to do integration test. Look at number 1. You don't even have to do integration test. Why? You know this kind of series. What kind of series is this? Geometric series. Do you recognize that? So you need to recognize this. If you want to save your time not doing all this hard integrations, you need to recognize. Not necessarily I will give you a geometric series as your homework, as you said, but you need to at least recognize this. You can save yourself time. So this number 1, I can do right away. What is it? I can rewrite this as what? N equal to 1 to infinity over what? 1/9 to the n. Right? And then you say, oh, this is wrong because you need to start with which one? 0. So you're going to say, oh, I can make it to be same by doing what? N equal to 0, 1/9 to the n minus what? 1/9 to the 0. Okay? Then you can figure out what that is. Okay, then you're going to say, okay, so I'm going to look at this. You're going to say A is 1, R is equal to what? 1/9. So what's your sum? A minus what? 1 minus R. In this case, you need to also do which one? You need to also do this part, which is minus 1/9 to the 0, which is the same as what? Is the same as 1? So you're gonna figure it out. It'll be what? 1/9, 1 minus 1/9 minus 1. Whatever that is, that's your answer. So what I just saw was what? Finding a partial sum. But your question does not ask you to find partial sum. Are you with me, Cloud? Okay, read your problem. If your problem says find the partial sum, then you're gonna do what? A over 1 minus R. That's the partial sum. But it's not asking you, it asks you to do what? Take a derivative, antiderivative. So let's take antiderivative. So we're gonna rewrite this problem as integral, starting 1 to infinity, right? What else? I'm gonna replace that as 1/9 to the x dx. All right, how do you find, all right, how do you find integration of a number? Do you remember the 20 of them? Look at your 20 of them that I gave you. Look at the integration of a number. Look at that. Because you can rewrite this problem as, if you want to recognize it, you can rewrite this problem as 1/9 to the what? You can do negative x. And dx. Okay. Look at it. Do you have your formula? So I need to show you that formula.
Why is it negative?
Oh, it's not negative. Positive. Positive. Not negative. It's still positive. Okay. Let me give you a formula. Do you not remember the formula? Okay. If it's not here, it's in my lesson from 9 point. Wyatt, what lesson did I give you that? 8.2? Okay. Okay, look at what number. Number 7. Over natural log of what? A. You see that? And plus the times what? A of u. Okay, so we're gonna do exactly the same thing. Then what can you say? What is that equal to? According to the formula, then I'm gonna do what? That's the same as. So 1/9 does not change, right? 1/9 stays there. So what do you do? What did you say? You said what? Natural log of what? A. Okay, so what is the natural log of A? So 1 over natural log of what? A is what is about 1 over A is what? 1/9. Okay. And what else? And then A to the what? Okay, so A will be 1/9 to the what? X. Okay, that's what I have. I'm just plugging into my formula. That's what my formula says. If I have A to the U, I do what? 1 over natural log of A times A to the U. So that's what I did. Okay, now I need to do what? Evaluating n equal to 1 and n equal to what? Infinity. So I need to take a limit. If you have an infinity, I need to do a limit. So I will do a limit class. Whenever your upper bound is infinity, you just take a limit. Are you with me? Because we don't know how to take integration of infinity. Okay, so take a limit. I'm gonna call it B. How about I call this be B? So B goes to infinity. I'm gonna take a limit of this. Okay, remember, so I'm gonna plug it in at infinity. So I have 1 over natural log of 1/9. I'm still having a infinity in the front. And 1/9. And then minus 1 over natural log 1/9 times 1/9 to the 1. Are you with me, class? I'm just plugging it in. lower limit. So far, so good? Okay, now, let's look at, if I plug in infinity, what happened here? If I plug in infinity, this thing become a what? Very, very small. 1 over 9 to the infinity, which is 1 over 9 is less than what? All right, class, look at this. If I give a 0.1 to the, say, 100, let's just say 10, something you know, 10. What does that mean? You have a 0.1. How many zeros? 9 zeros, right? 2, 3, 4, 5, 6, 7, 8, 9 to the 1. Are you with me, class? So if you do 0.1 over 9 is a decimal number. Are you with me? It's a decimal number, like it's almost like 0.1, a small number. So if you do 0.1 to the infinity, what do you get? Practically, what number is it? 0. Okay. So this whole thing become a what? 0. So what are you left with? This. Okay, so that's your answer now. So now your answer looks like this. This is what you have, right? So we need to look at this. No, look at the natural log. Natural log, what's the properties of natural log 1 over 9? Just look at this part. So natural log 1 over 9 is the same as natural log 1 minus natural log what? 9. Okay, natural log 1 is the same as what? 0. You're supposed to know this, okay? Or if you don't know it, you need to write it down, your properties of log, okay? Then what do you have? Remember, you have a negative in the front before, right? So now you can rewrite it as negative 1 over what? Negative natural log of 9, and you have a 1 over 9 in the front. This negative came from being a lower limit. Are you remember? You have upper limit here, minus lower limit. Right. This is upper limit that become a 0, but the lower limit is this. Are you with me, class? Right. Now this negative and that negative make it to be what? Positive. So which is the same as this answer right here. So integration test means you need to take integration of your given function. That's what that means. But remember this, you cannot use integration test unless the function is continuous. Are you with me? And function has to be decreasing.
So the function is 0.
So if the function is not decreasing, you cannot do integration test. Then you can do integration test. So in other words, you cannot just do integration test on anything. So this given function, okay, it is a continuous function. It is decreasing. Why? When n gets larger, this gets what? More close to which number? 0. So it's a decreasing function. That's why. So you can do this numerically, showing that it is decreasing, or you can do algebraically. How can you show it's decreasing in algebraically? Take what? First derivative. Take a first derivative, it's a decreasing, then you know it's a decreasing. So you can do both ways. So what I did for your problem, example 1. For this example 1, I want to know, okay, whether this converges or diverges. I want to try which one? Integration test. Look at this problem. This problem is not a geometric series. This is not a telescoping series. Is everybody with me? So I am forced to use what? Integration test. Is everybody with me? You have to decide it, because when I give you an exam, I'm going to say, find whether this is converges or diverges. If it does converges, find the partial sums or something. I'm going to ask. That means I'm not going to tell you use integration test or use p-test. I'm not going to tell you this. You're going to try and see which one you want to try. Everybody with me? Okay, for this particular problem, you know yourself. This is not a geometric series. This is not a telescoping series. So you have to do some kind of test. So I'm going to ask you to do what? Integration test. Okay, integral test. All right, to do the integral test, make sure that your function is what? Continuous, positive, and decreasing. So how can I find that? I can do numerically. First thing, I just define this. I'm gonna run this using a query. Run this. Look at your function. This is continuous function. It's a continuous. What is this? Is it decreasing? Yes. Start it right here, then what happens? Getting smaller. So yes, it is continuous. It is positive. Why is it positive? Your zero is right here. All the function is above x-axis. So it does meet the condition of integral test. Integral test have three conditions. What is three conditions? Tell me again. Has to be what? Function has to be what? Positive. Function has to be what? Continuous. Function has to be what? Decreasing. So yes, it is. So now we can do the integral test. All right, so integral test. I'm gonna replace n with x's. Okay, is everybody with me? Now, all right. So as you can see, I replace n with x. So I can take the integration. So now look at this: x over x squared plus 1. Does anybody recognize you can do substitution right away? Because I can put denominator as my u. X squared plus 1 to be my u. What's my du? 2x dx. So I'm going to replace that as my what? U. All right. And I need a 2. I don't have a 2. So what am I going to do? Multiply by 2 and then what? Divided by 2. Are you with me, class? You're not with me. I need a 2x. But I only have x. So what do I need to do? Multiply by 2 here, and then what do you do? Divided by 2. I'll put the 1/2 in the front. Because 2 over 2 is the same as what? 1. I'm not changing my problem. I'm just manipulating. Okay, calculus and algebra class, you do a lot of manipulation. Algebra manipulation. This is what I do. I put 2 in the numerator, I put the 2 in the denominator. So I need a 2 here. So this become a what? Now they become a du. All right, does everybody see that? So I'm going to replace everything by du. What do we use? Natural log of u. So natural log and u, I'm going to replace with the u with what? X squared plus 1. All right, then 1 to infinity. But I told you we cannot put infinity to the things because it's not allowed, right? We have to take a limit. So I'm going to put the 1/2 in the front, which does not do anything. So limit b goes to infinity. I'm going to replace that with a b. All right, and then you go to x squared plus 1. Okay, so put the b. I'm replacing x with the b squared plus 1 minus natural log of 1 plus 1. The second lower limit is 1. So this is no big deal. Natural log of 1 plus 1 is what? Simply 2. Natural log b squared plus 1. That's just a huge number, right? Plug in, now replace b with infinity. What's natural log of infinity means? It's a huge number, right? So this whole thing becomes infinity. So infinity minus some number is still what? Infinity. So is this convergence or divergence? Divergence. That's right. To converge means you're going to have what? Some number. I don't know what the number is, but it's supposed to be number. Then it's a convergence. All right. So that's how you do